In this video, we will read a document called the subject report, and you will understand more about the feedback from the examiner in the past few years on IA. I read 2 years of subject reports on IA. One is 2019 May session, the other one is 2018, also the May section. I find the 2018 that one is more detailed and useful, and therefore we will focus only on 2018. If you're interested to find and download the original document, I will put the link in the description below. You can always download it. Okay, so the first thing is about the range and suitability of the work submitted. And as you can see here, it said the topic or research question range from very basic one like Hooke's law for rubber band, or very sophisticated one like something to do with water rocket or measuring the Earth magnetic field. And they also talk about some general topics like Gauss gun, projectile motion, temperature, viscosity, or musical string resonance, etc. These are done many times. So the most important thing is you can see is that the results vary from poor work to outstanding work. So that means it doesn't really matter which topic you do. It's more about how you approach them. So for example, like covering all the details like the previous assessment criteria that we talked about in the last video, and also you can design a maybe more creative approach to find the relationship between the independent variable and dependent variable. And lastly, try to compare with the accepted literature result. So I think these are the very important idea to achieve a good work. The research question, I would say as a teacher, I always encourage students to have, of course, interesting topic rather than maybe just studying how maybe a certain temperature affecting refractive index of, say, syrup, which I don't know why we want to know that. So for those topics, I think it's fine, but then again, I still prefer to have a more interesting research question. And you can see here that it said the most successful investigation should be having a well-defined research question, clearly identify variables and appropriate means to measure and relate the variables, and appropriate and known scientific background. So basically all the things that we just mentioned in the last video. Personal engagement. Let's take a look at the strength first. So it said like what we said in the last video, personal engagement is assessed holistically. So not a session where you just put down I love music, I want to study violin, and therefore I study about the Hooke's law of the violin string. And if you are just performing an investigation with a so-called standard method, with standard analysis, you probably just earn 1 mark for PE. So like I said, normally you just get 1 mark. All right, if you really aim for 2 marks in PE, then you would really need to have an innovative mindset to have an interesting approach to the question, as well as understanding the background knowledge about the research question that you are studying. In terms of the weakness, as you can see here, like we said, students often overemphasize personal significance by writing what seem to be artificial comments about their interests. So they can really tell whether you are simply faking it or not. Like I said, if you are passionate about a certain research question, you know about the relevant concepts, the most detailed parts of the knowledge, and also what people did in the past as well. And so a full page of personal history playing musical instrument will not be appreciated. Exploration. The main takeaway here is that you should always do one and only one well-defined independent variable. And by that case, you should also have a dependent variable that is quantifiable, and that also means that you will be able to measure it. Some people may think of doing 2 independent variables, and it is totally wrong. It is explicitly said in the exam report here that if you spend the time to do 2 independent variables within 12 pages, at the end you would not have an in-depth discussion. So you only should really do one independent variable only. At the end, you will be establishing the relationship or mathematical function between these two variables, obviously. Some people may also choose to determine an important scientific constant like we said just now, like the Earth magnetic field, or it could be things like solar constant, etc., or even elementary charge. However, I will think finding out those constants is indeed more challenging, and you should always read much more literature on that, because there are many other people tried and attempt to find those scientific constants. And so there's no excuse that you said, you cannot find other literature to talk about. Here, they also mention some interesting and successful investigation. I will put the link of the video related to that. So if you're interested, you can take a look. I would just say they are just example, just to maybe give you some insight on what could actually be done. They also said here, if you remember, you can also do database and also computer simulation. But then, well, I guess you can try to read it by yourself. These are some examples, but ultimately, I would still say I personally prefer and recommend you to do the traditional practical work if possible. Because in the computer simulation or database, it will be harder to consider and show your skills on error analysis. Weaknesses. So once again, you can see here that it said there are some students try to do more than one independent variable, and again, that is not going to be good for you. The other thing is there are often some existing research that you can find, relevant concept that you can find, and that will be very useful to do your academic research. However, you should not make up physics-like explanation. So that's why whenever you want to do the background research, really you have to spend your time on Google to find established scientific paper. So the reliability of your source is very important. The other thing, once again, talking about the history of yourself, spending 2 pages on that is simply irrelevant. As for the procedures, if you remember, for exploration, that should include the procedures. You do not need to give a step-by-step codebook-like instructions. So for example, you don't have to say, plug in the cable of your oscilloscope, press the power button. You don't have to say that, right? So just try to put the most important steps, the most essential steps, especially those that will affect your accuracy and reliability of your data collection. And here you can see they also complain that quite many people in the past did the refractive index and how that will affected by maybe the concentration or temperature of the sugar or salt solution. Really, usually is not scientifically interesting. I mean, there will be relationship that you can find, but then why on earth would you like to study this? And there are also some meaningless investigation, like relating the distance covered by the wheel in one rotation as a function of wheel diameter. This one, to be honest, nothing to do with physics, but more like mathematics, because they just have such a simple geometry relationship. Or things like how the power affected by the time, or the mass affected the moment of inertia. So you can see the two variables are somewhat dependent on each other. So really make sure that your topic is really approved by your supervisor. Analysis. Most of the things here that we have already mentioned or will be mentioned in detail soon. However, one thing that you should pay attention is you would need to show sample calculation. So for example, how the error is propagated. So those calculations should be shown as an example for one of the trial. However, for some simple calculation, for example, like taking the average, according to what they say here, it is not required. However, I would say if you have enough pages, like within 12 pages, I would still fit them in. if possible. Weaknesses. So first of all, for the column head, they said you should always include the quantity with unit as well as the uncertainty with the units as well. That is to say, I guess some people, they only remember to put units for quantity but forgot to put down the units for uncertainty. For details, we'll be covering this in the later videos, and we will show you some example for that. A good column headings would be very helpful for the reader to understand your essay and also helping you to improve your communication aspect. The other thing is about the word or the term called proportional and linear that were not always understood correctly. So once again, to quickly explain this, proportional function is y equal to kx. That means it would pass through the origin, while for linear function is a broader idea where in terms of mathematical function is y equal to mx plus c. That means it is a straight line, but it may or may not pass through the origin. To understand more about this, if you want to, I make another video called 12 mistakes in the IA. You can try to see, there's a link on the top right corner. Moving onwards, it said there is a number of times that a student obviously show the data suggesting a curve fit, but then that student still falls a linear fit. So you have to understand that linear fit is not always the solution. If the data really show a curve, then you should do the curve simply. If you could linearize it, that would be another issue, and of course it will be appreciated too. And especially when you apply, here's a very good idea. You should think about when you put a linear fit, all right? No matter you are forcing it or not, for sure that if you think about the graph, there must be a time where the straight line will hit 0 of one of the axes. So you should think about whether or not physically it will be possible or not. And that could be one way to help you to discuss and understand your mathematical model, whether it fits the physics concept. Next, the examiner complains about the understanding of when to take the sig fig and when to take the decimal point correctly. So for example, if you are adding 2.345 plus 1.2, you should only express the answer as 2.5 because you should take the least decimal point, and instead of taking all of them, which is 2.545 here. This is something that you should have learned in chapter 1. As for the significance figures, then you should think about when you do multiplication or division, you should run off to the one with the least significance figure from your raw numbers before you do the multiplication or division. So for example, if you have such a calculation, 1.2 times 2.34 divide 5.678, in your calculator you get these 0.494540 something, right? According to the rule here, then you should only take the least SF, which here you can see 2SF, 3SF, and 4SF. So ignore the 3 and 4, you just take the 2SF. So that means the answer is 0.50 in this case. Evaluation. Like we said, when there is a known scientific context or accepted value, you should always compare with your result with that accepted or literature value. There are times where you may not have that. So in that case, you should still interpret your own values or data with the accepted scientific context. For example, when say a student try to find the refractive index of water at 85 degrees Celsius, he or she find out is 5.2, which is impossible because for like diamond is 2 point something, so there's no way that you can have that. But I'll say still, if you want to have an easier life with your physics IA, the best is whenever you design a certain research question, it will be the best if you already find a certain scientific context giving you the relationship from other people's experiment, saying that maybe it's linear, exponential, or whatever, it will be the best. Because in that case, then you can have a meaningful discussion between yours and their result. Secondly, here is that the most successful student report will show an appreciation for any assumption of their methodology. So say if you're doing a motion mechanics, usually you assume there's no air resistance or no friction. So in that case, you should again discuss whether this is true in your evaluation part, or whether or not those control variables in your experiment are really constant throughout the whole experiment. Weaknesses. Here is one really important idea that you should learn, not only from physics but also in the points of TOK. In science, we never prove anything, especially for you. I mean, not trying to devalue you guys, but it takes a lot of effort and time to prove something. And in fact, in science, we never prove anything. We only verify and provide evidence to support a certain theory or model in science. So never put the word proof in your IA at the end or anywhere. So things like I'm pleased with my result, I proved my hypothesis, things like that would really give a bad impression to the marker. The other thing is when you try to construct the mathematical model, if you simply fit a polynomial equation into your data to just fit it, it would not be meaningful if you do not have any physical meaning given to that equation. And quite often I don't find what we learn mostly in or most common research question in IA would involve the polynomial equation. Remember, this is a physics IA, not maths IA. And so you must make sense of the equation, especially on the two end, whether or not it would fit with our physical understanding. And here is an example. It sets the graph of a student plotting, investigating the mass and the period of simple harmonic motion oscillator. With zero mass in the system, it will still oscillate with a period of 4 seconds, which is again impossible. And you can still plot that graph. It is not really your fault that maybe having that data collected. Instead, you should be addressing that in your IA, and you should give an explanation to that and telling us that this should not be sensible and reliable. And they also reiterate you should avoid blaming the human error or friction all the time. And there are times where you simply make false claim like systematic error when the best fit line was inappropriate, simply like maybe it was supposed to be a curve fit, but then you use a linear fit. So those things we will cover more in the evaluation in the later video. One thing that I think is very important is if you look at the assessment criteria of the evaluation, which you can refer to the previous video, you can see that for lower band and higher band, it has actually mentioned the procedural issue and methodological issue. All right. So for the lower band, which it means you only focus on the procedural issue, then you would not be scoring high. Example of procedural issue is like suggesting taking more data, like repeating more trials, or simply just extending the range of data. So these are procedural issues because this can be applied to any other topic in your research question. So it's just too general. In order to achieve a high marking bands in evaluation for making suggestions, you should be addressing the assumption in your method, which it really depends on what research question that you're talking about. And maybe you can even suggest new ways to measure the quantities or alternative approach to the research question, like another methodology simply. And which of course it should probably hopefully get a more precise or accurate value at the end. Communication. Some key points that you need to know. First of all, again, like personal engagement, it is assessed holistically, so you have to be simply clearly communicating with your audience all the time throughout the whole IA. Second thing is the title of your report should directly be your research question, like how temperature affects refractive index of water, instead of a very simple title like bending light. They also mentioned that the rule we said there was 12 pages limitation. It said it is clearly that 10 pages is in fact enough for a reasonable and concise IA. So really try to limit yourself within 12 pages. Even though it said here there was a case where a student did 16 pages in his or her report and was not penalized in the communications, I would still say do not take the risk. Stick with 12 pages for the maximum pages. In a case where you have too many information to show, you can always use appendix to help. Remember, the difference between your actual content and appendix is, for appendix, you should not expect the audience would read it. So they should be able to understand the whole report without reading the appendix. Next, there is no clear rule saying how many or what font size you should use, but then they would say 8 will be too small, and using single space paragraphs will be too packed as well. Usually I'll recommend maybe 11 or even 12 font size with maybe 1.5 line spacing. If you have any picture or diagram or anything that you simply copy from a source, you must reference it directly, so not just leave it in the reference list. It is emphasized here that it is not really about communication and you won't be penalized on this, but then it is actually a serious IB issue of academic honesty. So for example, you took someone's experiment setup diagram and did not give credit to them, and people would just assume that's your own work, and that is a possible plagiarism of other people's work. And this is very serious. You may be simply failed from the IB. That's all for this part of video. In the next part, we'll talk about how to choose a good research question.